We are continuing with the textbook exercises. Give a brief description of the principles of the following techniques, taking in example and in each case, and their crystallization, distillation, and chromatography. So in case of crystallization, the basic principle is the fact that there is a difference in solubility of the compound and the impurities in a particular solvent. So we are we are making sure that the impurities are not soluble in that particular solvent, and I'm sorry, are soluble in the solvent, and the compound is not that soluble. This will make sure that we're able to separate the substance from its impurities. Example can be crystallization of sugar or various salts. Next is distillation. So distillation is the basic principle of distillation is the conversion of liquid to gas on heating, and then the conversion of gas to liquid back on cooling. That is what we had studied, right? So this gets heated, and then in the condenser, it cools down. So the gas gets converted back to the liquid in the condenser. So what happens is the impurities will stay back in the round bottom flask, whereas the pure compound comes out from the condenser. And various solvents like benzene, toluene, all of these are purified by the process of distillation. The last is chromatography. Chromatography actually, basic principle for chromatography is the separation of the compound and its impurities or compounds in the stationary as well as in the stationary phase. So the mobile phase will make sure also make sure that the compounds get separated, and you can elute the respective compounds based on the stationary phase. So based on that, you have two types of principles: adsorption and partition. Adsorption was mainly to do with the adsorption of that particular substance on silica or the stationary phase. Partition is basically the division of the particular substance in both the mediums. We had discussed all of this in detail, and chromatography is also basically used for the separation as well as the purification of compounds. It also helps us to test the purity of the compound. The next one, describe the method which can be used to separate two compounds with different solubilities in a particular solvent. So we have a solvent S, and these two compounds are soluble to various extents. So this can be separated by a method called as fractional crystallization. So what happens is, here we are going to make a hot saturated solution of these compounds, okay, and we are going to let it to cool down. Remember, in crystallization also we had made a saturated solution. The same way we are going to be making a saturated solution of these two compounds. And when it's cold, it starts to cool down. The one which is less soluble will crystallize, okay, and we can separate it by the process of filtration, right? And the one which is more so again, after that, by filtration, we remove it out, and we'll obviously clean the liquid which is left, right? And then we'll wash these crystals, and obviously you'll get more amount of you'll get the other substance dissolved in that particular solvent. And then what happens is, we will be heating the solution again, and then it is allowed to cool, and we are getting the compound like we did in crystallization. So when we have two compounds with different solubilities in the particular solvent, we're heating it to form a hot concentrated or hot saturated solution. So when we cool it down, the one which is less soluble will separate out. We're separating it, and then we'll get the more soluble one, and then we'll separate it as well. So that is about fractional. This method is called as fractional crystallization. The next one, what is the difference between distillation under reduced pressure, and steam distillation? So we've done this in detail in the previous videos. First of all, distillation. It is basically the conversion of liquid to vapors, and the vapors will consist only of the pure compound, and that is going to get basically converted back to a liquid, and you will collect that. So this particular method is especially used for the compounds which do not get decomposed under high temperatures. So they do not, they're able to undergo the process of heat boiling, and they don't undergo decomposition. And also one more important thing, this is also used for substances which have a huge difference in their boiling points. If we are using liquids, we'll use them for a high difference in boiling points. Next is distillation under reduced pressure. So in this case, it converts the liquid to vapor and in heating, and this is followed by the cooling of the vapors which are produced. But this is done under reduced pressure. Now, this is done, the pressure comes into play over here because these liquids have a tendency to decompose below their boiling point. So when we heat them to their boiling point, they'll undergo the process. I mean, closer to the boiling point, they'll undergo the process of decomposition. So we don't want to extend it to the, we don't want to boil this. Instead, we're using pressure as well and making sure that the liquid gets converted to its vapor. The last one is steam distillation, similar to the one which we talked about, that is reduced pressure. But in this case, we are separating it. We're separating and purifying a liquid which is highly volatile. And in steam from so we are going to be separating it in such a way that we are using steam in this case. So the steam is going to aid the process of distillation, and basically the vapor pressures are the one coming into play. So the organic, we discussed this in detail in the videos that we've done about when a particular vapor pressure becomes equal to the atmospheric pressure, that is when it gets converted to vapor. So the organic liquid and that of water gets added up, and makes it in turn makes sure that the substance is going to get heated, and in turn that gets separated. Next one, discuss the chemistry of Lassigne's test. So Lassigne's test, the basic chemistry behind it is the fact that we are converting a covalent bonded atom to a ionic bond. So nitrogen, first of all, so the basic method is we're heating it with sodium, and then we're going to basically make sure that this particular respective compounds are formed based on the element which is present. So if nitrogen is present, both carbon as well as nitrogen will form NaCN, right? And sulfur will form Na2S, NaX will form Na plus X will form NaX, that is halogens. So this method is making sure that the covalently bound atoms are converted to ionic ones. And this in turn will be easy. I mean, we can detect them by the various tests that we had already discussed. Explain the principle of paper chromatography. So principle as in, it's first of all, paper chromatography comes under partition chromatography. So here there is a differential partitioning of the components between the stationary and the mobile phases. So in stationary, so the component is going to split in, a partition in the stationary phase, so which is the paper strip which has water trapped in it, whereas the solvent itself is going to act as the mobile phase. So we'll use a solvent which helps separate the components, and we can observe them. The next one, why is nitric acid added to sodium extract before adding silver nitrate for the for testing halogens? So if you remember, when we discussed about Lassigne's test, I told that when we add, when we have both nitrogen or sulfur, when we have either nitrogen or sulfur, we need to we need to add nitric acid to ensure that these do not hinder with the test. So if they are present, and if we do add silver nitrate, then if nitrogen is present in the compound, it will lead to the formation of silver cyanide, and this is a white precipitate. And if you remember, when AgNO3 is added to NaCl, basically, that will lead to the formation of silver chloride, which is also a white precipitate. So we might get a wrong we might get a false positive test. One more thing, this is supposed to be a capital O. I am so sorry. The next case is Na2S. If Ag2S is formed, it will lead to the formation of a silver sulfide, which is a black precipitate. I know it might not, but this would again hinder the formation of the black precipitate, would hinder the color observations of the halogens. So that is why we are first treating the sodium extract with nitric acid before we are adding the silver nitrate. So when nitric acid is added, sodium nitrate is formed and HCN is formed. And when Na2S is added, when sodium sulfide has as nitric acid added to it, it leads to the formation of, again, sodium nitrite and H2S. So these two reactions, H2S is going to basically be expelled into the air, and so is HCN. These two are gases, so they will not hinder the reaction. This makes sure that we can, we do not have a wrong test. The next one, explain the reason for the fusion of an organic compound with metallic sodium for testing nitrogen, sulfur, and halogens. So the reason we have to fuse them is because of, again, similar to what we had discussed in the previous case, it's to convert these elements which are present in from the covalent form to the ionic form. So the moment they are converted to the ionic form, it is easier for us to observe that, we are able to add various compounds and test the presence of those particular elements. And this makes sure that it's, so basically, basically we're just converting them from covalent to ionic. Next one, name a suitable technique for the separation of components from a mixture of calcium sulfate and camphor. So the first method that comes to mind is obviously sublimation. So camphor is a sublimable substance, whereas calcium sulfate is not sublimable. So basically the solid, so camphor will convert to gas, and on cooling it will convert back to solid, whereas calcium sulfate does not undergo the process of sublimation. So there is another method which can also be used. First of all, camphor is soluble in solvents which are organic. Okay, and these solvents include calcium chloride, carbon tetrachloride and CHCl3, carbon trichloride, etc. So CaSO4, on the other hand, is not soluble in such solvents. So we can also use the method of crystallization. So we're going to just shake the solvent with, shake the mixture with the solvent. So camphor will get dissolved, whereas the impurity in this case, the other component in this case, calcium sulfate, will not. And by the process of filtration, we can remove the calcium sulfate and we'll have this solution of basically camphor in that particular solvent. And this in turn, evaporation of this particular substance will lead to the formation of camphor. And that's how we'll be able to separate the mixture of camphor as well as calcium sulfate. The next video, we will be continuing with the textbook question.